Hi, my name is Murat, and in this video I would like to talk about how to choose a large language model for your specific task. I am engaged in LLM professionally as part of my job. So my main task is to help for startup founders, especially those with a non-technical background. It's important to choose the language model that would help solve their users' problems. In addition to that, I am a lecturer in the master's program at FKN in their schools of economics. So what I want to share with you might be useful. This won't be a very technical conversation. Rather, it's more about setting a certain mindset before diving in and drowning in an ocean of various possibilities when selecting an LLM. So let's give it a try. Let's talk about what we will be discussing today. I would like to first talk about what there are ways to think about your task before you start selecting or tuning a model. After that, we will talk about what options are currently available in the industry. And in the next part, we will talk about the metrics and benchmarks that will help us choose something from these options that suits us. So before we start thinking about selection or tuning, I would like to, in general, understand in what format our users will derive value from the product we are creating with or based on the language model. There are different ways. For example, one of them is this from the forks use, P, let's say, the same one. Cloud from Anthropic or ChatRapsh 5. An alternative is to take the model weights, deploy them somehow, and provide users with answers based on your deployed model. Both options have their pros and cons, as you can imagine, but they are not as trivial as they may seem. Because I often hear that you want your own model. It is not always justified. Wrappers around the HPT chat. It is not always about scam. In general, there are situations when you just need to quickly prototype something and therefore waste time. Deploying your own model can be fraught with danger, especially if you don't have a team with the right expertise that tackles such tasks for breakfast. So it happens that if you're working with very sensitive data, like financial, medical, or even legal data, you just can't afford, no matter how much you might want to hand that data over to some hypothetical OpenAI. In that case, unfortunately, or perhaps fortunately, you'll have to set up your own model, and that's kind of a choice without a choice. Therefore, rather some restrictions that are formed by the nature of the task you are solving. So I need to choosing ChatGPT, so to speak, its IP versus your own deployed model. It's not a choice. It's more of a choice imposed by the limitations you have. If you want to move quickly and you have the skills, or on the contrary, if you don't, then by all means. ChatGPT isn't so bad for trying things out. You can raise a round and maybe hire a team. Secondly, there's an understanding that for certain tasks, the models that are available, for example, in general access, might not be sufficient. For example, there's OpenAI, which creates ChatGPT. After this model was trained on a large corpus of text to generate the next token, OpenAI very carefully, figuratively, hit it over the head for the fact that it was, let's say, toxic, and for the fact that it released data that, in a neutral sense, OpenAI decided to censor. Accordingly, when you use such ready-made solutions, you inherit all those restrictions that were imposed by the company, the team that worked with the original model. So before choosing a model, it would be good to understand in what way exactly there was tuning or alignment of the lookout model with user expectations. Was there any censorship that might be incompatible with your specific task or not? Secondly, if you have, let's say, some private data generated by your process or your team, then probably you need to fine-tune the model, and you don't have much choice here. So basically, what are we even talking about here? Thirdly, what's worth discussing is hardware, for example. The hardware limitations you might have. Sometimes your model needs to work quickly on your client's device, and it's always a non-trivial choice. It turns out that you can put a large model in the cloud and in large buckets, so you can either provide answers to users on demand or deploy a lighter model on your client's specific device. And maybe that will be enough. That's always a tricky question, so please keep that in mind. Also here, Unfortunately, in the current reality, you don't always have access to the cards you need for the model to process. And that's why the size of the model you will use can be important. The bigger the model, the more requirements there are, not just limitations on the cost of generation, and that's because you simply may not have the necessary resources physically. In addition, it's probably worth considering that different models have their own various strengths and weaknesses, whatever it may seem, right? So accordingly, there are models that have a very wide contextual window. Accordingly, if you need to summarize large pieces of text, some articles, it is probably good to take a model that has a broad context, and it would be better if it were sharpened for such a task, so that it would work with Turkish, Paperitei. Let's say there are times when you need to translate text or work in a multilingual environment. Then you should probably choose a model that can work not just with English, not only with the Russian language, but also sharpened for a broader range of languages. Here I have all sorts of limitations. It is also important to keep them in mind, and they can be most sensitive to model selection. An obvious thing is that your model needs to speak the language of your clients. If it doesn't speak Russian but hits all the metrics, that's a bad model. But if we come back down to earth, then true, good models that hold up well, say, in a multilingual environment may be inferior. Much more generally weak models, but which are tailored specifically for the language you need. In this case, let's say Russian. So please keep that in mind. This might give you some advantages in business, for example. Besides that, I see this point too often to skip it. You might want to consider maybe you don't need it. So this huge, biggest model that solves everything better than anyone else, it might be better to choose a smaller model that is, in general, sufficient for your task. For example, it could be charge 535 versus charge 540. If you have, for example, there's some service that forwards or makes a record of clients of a nail salon, and in general, charge 535 is enough. So please, there's no need to go for something bigger. It's obvious, but you'd be surprised how often I see the opposite story. Besides that, it sometimes happens that even within the same model family, the question arises, if you're familiar with what quantization is, what's better? To take a model with, say, 140 billion parameters and compress it to 4 bits. Yes, like 4-bit quality, or to take a model with 70 billion parameters and compress it with less quality loss. You'll be surprised that probably many expected that 140 billion would be better, but very often in practice it turns out that 70 billion parameters are preferable. So please don't torture poor models in conditions they weren't trained for. Accordingly, often the 70 billion model in 8.5 is more than enough in general. Look, the choice is enough. It's simple, actually. Besides that, there are a lot of scenarios where you can simulate. The pipeline you need, for example, you need some classification of incoming requests by different support categories. Perhaps you don't need some charge PT. You don't need a big llama with 70 billion parameters. Some BERT is enough for you, which you will simply fine-tune on your data. You will receive. In general, the quality is pretty good. I mean, good enough. In general, a general recommendation, start small, maybe that will be enough, and move forward only if you need something more and you have received confirmation of this in practice. And, of course, an important point is that the license should allow for commercial use if you're planning to do more than just research. In general, there's a bit of a zoo presented on the website. Models that are currently represented in the industry. I think basically that's the slide. This could be supplemented with a very large number of models. But you need to understand that models appear like mushrooms after the rain approximately every few days, and all of them, of course, are better than everything that was before. So remember, it's not worth it. This slide is more for those who are basically trying to figure out what's going on, what options are available, and where to even Google if you need something. In general, from what works with GSAP, and Chad is just playing around. There he is. And now, we expect that the Google model Gemini will take its position. In practice, I guess I may not be representative, but 60-70% are use case For some reason, everyone wants to close it with Llama, but everyone has heard of it. It's really not bad. Therefore, basically, if you want to take something open source and deploy it yourself, Llama is a good choice. Choose options that suit you. There are lighter alternatives and some that work with images. In general, depending on your use case, choose what you need. There's a conditional BLEU that can handle many languages, but overall, it actually falls short compared to Llama in almost all parameters. There is Falcon, Mistral. In general, there are many options. I advise you to do the following. Look at the strengths and weaknesses of these models. Let's say BLEU knows a lot of languages well for you, and you can compare that with what the requirements are for your task. If you work with a lot of languages, it probably doesn't make sense for you to take, say, Falcon, Mistral. Take BLEU in general, choose a model for the task and not the task for the model, probably the general rule. If you're working in a Russian-speaking environment, then it's GigaChat, ROUGE GPT, Yandex, or GPT. They are, in principle, more or less tied to their parent companies. Yandex GPT, well, they're not bad at all, but they are integrated into their own ecosystems. So if you're already working with them, you don't really have a lot of choices. The same GigaChat, for example, he is not available for commercial use. In any case, only for research. But there is Yandex to GPT. Basically, it doesn't leave you with alternatives. If you're working with Yandex.GPT products on a large scale, if you're looking for something open source, then consider Delight and Tepro. They allow for commercial use. These are finalized models from the team of the former Tinkoff Thai Bank. The guys have done a great job. I've heard a lot of positive feedback about them from the industry, so please make use of them and check them out. They have a cool article on Haber if you need something to get started. There's Vikri, a team of enthusiasts who are developing models specifically tailored for the Russian language. So the models, that's also a good review from them. I'm getting it. I recommend you read it. I think they also have something on Hebrew. Good articles. And choose a model based on what you like the most. But from the latest hype, as far as I know, I think T-Lite will outperform Vikri on various benchmarks and metrics. But you should approach this with a bit of skepticism. We'll talk more about this in general, and both are good choices. If you need something more universal, go for LLM, which is distributed by Meta. Basically, you can't go wrong with that either. So now let's talk about metrics. I wouldn't want to make this conversation overly technical, but it's important to say that we would like to compare these models with each other, and you've probably definitely heard about metrics like Perplexity, ROUGE, BLEU, and so on. They have their pros and cons, but mostly their use is limited to the same model. So, for example, the same Perplexity you will use, for example, to evaluate the same model of yours, but it's quite difficult to compare the models with each other for the simple reason that, let's take a look at an example. Reflection is a fact, which is also cross-entropy. If you've worked with line max, then you know what cross-entropy is. So you're trying to use your model to predict the next token and compare the resulting distribution on the vocabulary with the factually correct answer that you've already seen in this position. So the problem is that if your model suddenly generates vague words or some synonym that might even fit the context better, then your metric will, in principle, penalize that heavily. She wouldn't want that, basically. So in a way, this metric is kind of dumb, but it's the best we have for training. Here's Perplexity with the accuracy of the monotonic transformation. It's the same cross-entropy. It just measures how confident your model is in what it has generated. Here, there are the Roche-Bell metrics. I also won't go into depth right now. If necessary, you can read the first article from the Google search results. The point is that you're trying to compare what the model generated with what we expected to see. They use recall precision, but that's not the point. It's important. What's important is that the model is tuned for an actual match with what you expected to see. And probably that's a bad story because, so look, first of all, as I said, the story with synonyms, your metric may not fully reflect, indeed, the quality of the model. Secondly, there is a problem with the fact that what if you try to compare two different models with each other? Using these metrics, the model, for example, that answers common sense questions will have a high metric. because it is not very difficult for it, and the other model, which does not do something really difficult. If some kind of reasoning is being attempted, it will often make mistakes more frequently than it gets things right. And you will thus get the wrong idea of your model in general. If, in short, try to understand what the essence of the metric is and how you don't rely on them as the ultimate truth. They're just a proxy, just some kind of hint that probably something is going right as we expect it to. To compare models with each other, there are more comprehensive approaches called benchmarks. I'll try to show you now. First of all, there are specific ones. Benchmarks like MMLU, massive multitask language. Understanding the idea is that you give the model a series of questions, provide it with multiple choice options, and it selects what it thinks is the most correct answer. Here is a Famashama, more complicated version of this option, which simply gives probably more complex tasks, therefore, in your model. But anyway, the point of all these benchmarks is that you're trying to simulate some kind of use case for your model and look at how it behaves in it. They are, again, not exhaustive, they are not the ultimate truth, but they give us a more or less accurate representation of the model. Moreover, let's say that even if we're comparing MMLU Pro and the original MMLU, then because the previous version is more complex, it works better when you give the model, say, a few shot, if you know what I mean. It gives the model, for example, some context. That is, the prompt contains some additional, let's say, chain of thought, representation of the question. That is, in true principle, the same model can behave differently depending on the nature of the interaction with it. So you need to be very careful. With these metrics, they're all just like some proxies, but they do give you a sense of what the model is like. So you can look at the overhead you want your model to, so that your model can solve something in math. In general, there are these leaderboards. I urge you to just take a look at what benchmarks and metrics are available here. Each of the benchmarks is just a published paper that shows, look, we collected some data, we compared it, and our model, it relates to other alternatives. There are specifically tailored leaderboards, for example, for Russian language models. For example, you can take a look at human eval here. That's how it writes. So the code is ready. You can take a look. If you want your model to handle coding tasks, you start by selecting the match mark that you want to evaluate in the model, right? After that, see which one performs better, and then take that one. This model serves as a basis. There are more complex, rather intricate benchmarks that try to consider various scenarios. One of them is Helm. I think it's from Stanford. The point is that you're trying to evaluate the model on reasoning, on some language tasks, like summarization and so on math, on generation speed, and so forth. You try to evaluate all of this, and then you look for an average temperature across the board, like how well the model performed overall as a kind of summary AGI. This is probably a good starting point for evaluating your model. But in practice, most modern problems that you will solve will require some narrow task from you. So, probably. Personally, I would first look at specific benchmarks, which, for example, are in leaderboards, compare with how your model behaves in them, and how you would start from that, and not from some general benchmarks that are good for just playing around, for example, with these models. But for each task, I would recommend selecting the metric on your own. Well, and accordingly, if you want to get a more comprehensive idea of the comparison of models, there is the so-called Arena chatbot. Here, roughly speaking, you give users, for example, comparing the generation from the same prompt using two different models, and users say which one they prefer. With these pairwise comparisons, you compare different models against each other, trying to establish some sort of order from these comparisons. And accordingly, you have a leaderboard that shows how often people prefer one model over another. However, there are more or less automated options, such as Arena Hard Auto, where the evaluator is a model, for example, GPT-4, which we consider to be the benchmark, so to speak. But again, it's all just a proxy for what you want to evaluate. Most likely, if you are going to solve your specific problem, I advise you just sit down and think about how you would like it to look. If you have the resources and an understanding of how it should look, you can create the benchmark yourself. And then you can track the progress of different models on it and find the best one. Or take the same model, fine-tune it, and see how it performs. According to the readings of this benchmark, anyway, who would have thought in the end it's better to just think a little bit for yourself and do not rely on any automated histories. However, they are a good starting point to try to assess the quality of the models. I hope that for many people who are just starting to get acquainted with relays, you won't drown in all this flow. Diversity. Don't worry, we're all in the same boat. Even those guys who have been in the industry for a long time, when they take a break and come back, they struggle to catch up with what's going on. That's the absolute norm. Unfortunately, you can't escape this. The industry is moving at breakneck speed. But as a kind of foundation, something worth looking at before diving in head first, I hope I could provide that for you. Thank you for your attention. If you have any questions, feel free to reach out. I don't know how, but in general, wherever you find this video, there will probably be some explanation of how this should happen. Goodbye, everyone.